Hello, welcome to my YouTube channel. Let's go ahead and start by drawing a circuit. Let's draw a resistor. Let's draw a battery. And let's put three branches on this resistor. That is the first branch, and the final branch will be another resistor. And let's draw a third resistor here. So now we got three branches. The branches, if you notice, they start from here to here. So you can tell that we got our three branches that are in parallel. And let's put our ground, which means 0. And let's go ahead and assign this to 8 volts. And the resistor, we'll put one at 4 volts, the other at 3 volts, and the other at 2. So 4 volts, 4 ohms. Let's put this at 4 ohms. 3 ohms. I hate this device. 3 ohms and 2 ohms. Okay. And let's do some analysis. Let me get a different pin for this. Okay. So we want to find this current. We'll call this current I. Let's call it I1. I sub 1. And from here to here, the positive part of the node to the ground, we'll call it V. And one property of circuits is that branches that are in parallel, they share the same voltage. So this V, it's true that it's from this positive to negative, but it's also true here. From there to there, the voltage is V. And the same with here. From there to there, the voltage is V. We'll leave it as V with no subscripts. And if you guys remember, let's talk about Ohm's law. Ohm's law. And Ohm's law is just the voltage is equal to the current times the resistance. I is always the current in electrical engineering. And V is always the electric potential, or that is the voltage. So this branch has its own current, and so does this. So this one, we'll call it the current through branch 2. And this one, we'll call it the current through branch 3. And Kirchhoff's current law says that the sum of the currents entering a node is equal to 0. So basically, the sum of all the currents entering a node is equal to 0. And here, let's look at this node here. So into this node, we have I1 plus I2 plus I3. So according to Kirchhoff, that means I sub 1 plus I sub 2 plus I sub 3 oh, this thing is equal to 0. So we have I sub 1, I sub 2 plus I sub 3 equals to 0. So we got one equation that we will use. Let me put a box around it. And this will call our equation number 1. Okay. Now let's find the current let's find the easy one. The one going through node 3 using Ohm's law. So our Ohm's law is V equals IR. And notice that I made a little v for the V. I'm gonna put a subscript on the V, and I'm just gonna put a little 1 on it, so we could distinguish. Since this is the voltage going through each of the nodes. So the V1. So let's use our good habit of parentheses, so that we could substitute in there. And we don't know what the current is. That's what we're trying to solve. So actually the current is also, we know what it is. So we'll put parentheses everywhere. So for the third branch, our voltage is V sub 1. Our current is I sub 3. This thing is so annoying. Technical difficulties here. Okay. I have to make ugly 3 so this device will take it. And our 3 ohms, we're going to drop the unit. For the resistance, we're just going to put the 3. We're going to skip the ohms. So that's supposed to be a 3. So now we have V sub 1 equals to, I'm going to try to write the 3 again. I sub 3 times 3. Okay. So now we got our equation for branch 1. No, branch 3, right? Now let's do the same. Get our equation for branch 2. And again, we're going to use Ohm's law. So let's do our V equals IR. And our good habit of using parentheses, so that we could teach the young ones the good habits in math. And branch 2 has the 2 ohms. So let's put our 2 there without the unit. And our current, we said, was I sub 2. And our voltage is V1. So now we have V sub 1 equals to 2 times I sub 2. We have another equation. And this is the one for branch 2. Now let's go to the fun branch. Notice on this branch here that the same current goes through there. And we called it I sub 1. And also notice that the total voltage across these devices is V sub 1. The same as any other branches, because they are in parallel. So let's go ahead and get the voltage from this little piece here, from this little resistor first. And then we'll call this, we can call this V sub 2. V sub 2. I hate way this This thing doesn't like it. But anyways, so what we're gonna do, we're going to do Ohm's law on the 4 ohm resistor. And that there is our V equals IR, and put our parentheses equals oh no. This is, let me get an eraser here. Let me get a pen again. And we know that the resistance is 4 ohms. And the current is I sub 1. And the voltage, we're going to call it V sub 2. This annoying thing. If anyone can tell me how to not get that screen. Okay. So now we have V sub 2 equals to 4 times I sub 1. And this is our branch 1. No, this isn't branch 1. This is for the 4 ohm resistor. The voltage across branch 1 is V1. We gotta use Kirchhoff's voltage law. Let's go and use it here. We'll do Kirchhoff's voltage law. And that just says that the sum of the voltage rises is equal to the sum of the voltage drops. It looks like I ran out of room, so I'm gonna put it here. Sum of the voltage rises equals to the sum of the voltage drops. Okay, and let's get a different pin for this. Okay, so we'll draw our loop here. We'll start at the ground where there's nothing, and then we'll go all the way around and finish here. And so basically our trip starts down there, and we go and encounter one voltage rise. And remember, the positive part of the terminal is positive. The smaller part is negative. So we have a rise, and this is 8 volts. So we say, let's write it right here. Or how about down here? 8 volts equals to the, what did we call that one? V2? V sub 2? No. This is also a rise, right? Because notice, as we move up, we encounter the negative first and come out of the positive. And here we encounter the negative first again and come out through the positive. So this 8 volts, this turns into a plus. 8 volts plus V2 equals, and here we start at a plus and come out on a minus. So that is equal to V1. Okay? I'll rewrite this equation. And we get 8 plus V sub 2 equals V1. Okay, so we got all these equations. Okay? So we got a real mess here. So we'll call this equation branch 1. Okay, so now what I need is gonna scroll this window down a little to get some room. This is now algebra. So let's go to this equation 1, which is I sub 1 plus I sub 2 plus I sub 3 equals to 0. So here is I sub 3 in terms of V1, and we have I sub 2 in terms of V1, and we have I sub 1 in terms of V2. I don't really like that we have a V2. So unfortunately, it seems like we have 4 equations, 1, 2, 3, 4 equations, and maybe like 4 unknowns, 4 or 5. I'm gonna erase some stuff we don't need. We don't need this here. Okay, so now we can count. We got 5 equations and 5 unknowns. I1, I2, I3 are the unknown currents, and V1 and V1 and V2 are the 2 voltages. So we got enough to solve this. Let's begin by solving for... Let's get rid of the V2s first. So to get rid of the V2s, let's use this equation and this equation. And we have 8 plus, and then we put our parentheses, equals V1. So V2 is equal to 4 I sub 1. So we put our 4 I sub 1 right there. And we're left with 8 plus 4 I sub 1 equals V1. Okay. So now we got we got 2 equations and 2 unknowns. Well, actually we got more, but let's do it again. Let me get a different pen so we can see what we're doing better. How about if we use this equation here for the V1 and this equation here for the I2. So notice these two equations. These are both V1s. So let's just set them next to each. Let's set them equal to each other. So you have V1 equals V1. That will give you 3 I sub 3 equals 2 I sub 2. Okay. So, and then we have not used this equation yet. Oh yeah, we did. So at some point we're gonna have to put all that into this equation. It's almost like I'm missing one equation. Anyways, let's use this equation now. So here, if we divide both sides by 3, we get I sub 3 equals to 2/3 I sub 2. Feels like I'm missing an equation or something. Okay, so I sub 1 plus I sub 2 plus I sub 3 equals to 0. And our I sub 3 is equal to 2/3 I sub 2. Right? So we can add these two because they're both I sub 2. That is occurring through the second branch. So we would need a 3/3 here, which is a 1. We're just getting a common denominator. And we have I sub 1 plus 3 plus 2 is 5. So we're going to get 5/3 I sub 2 equals 0. And basically we take one of them to the other side and we get I sub 1 equals negative 5/3 I sub 2. Okay. And the drama is on because it looks like I will not be able to solve all these currents. But I'm trusting the math. So did we hide an equation? It does not look like it, but if maybe we could write if we could write I sub 2 in terms of V1, we're home free. So I'm gonna use this equation here to write I sub 2 in terms of V1. So I'm gonna get some more some more space. I'm gonna write it on this side, and I'm gonna use a blue pin. So I'm gonna get this guy here and say I sub 1 is equal to negative 5/3. And let's put our parentheses for our I sub 2. And our I sub 2, we'll get it from there. Our I sub 2 is equal to V sub 1 over 2. I just divided both sides by 2. This cancels, and we're left with I sub 2 is equal to V sub 1 over V sub 2. So now let's substitute that in here, and we're left with V sub 1 over 2. And now we can solve for our I sub 1. And we get negative 5 over 6 times V sub 1. And this is good. This is good because now now everything becomes easy. We got 2 equations and 2 unknowns. We solve V sub 1 and we solve everything. And notice this one has the same unknowns. This equation here has the same unknowns as this equation here. So now it's a piece of cake. We will replace the I1 there with this. So let's get a fancy color for this moment. And we have 8 plus 4. We leave parentheses for the I sub 1, and that is equal to V sub 1. And we put negative 5, 6 V sub 1. Negative 5 over 6 times V sub 1. So we do our multiplication. 8 minus, because positive times negative is negative, 20 over 6 V sub 1 equals V sub 1. We take this to the other side of the equation, and it becomes positive. 20 over 6 V sub 1. Let's cross it out here. Now we multiply by 6 over 6 to get a common denominator, and we're left with 8 equals 20 plus 6, 26 over 6 V sub 1. Okay, multiply both sides by 6 over 26. And this goes to 1. And we're left with 48 divided by 26 equals V sub 1. So now the rest is easy because everything else is in terms of V sub 1. So our 48, we can take out I think that's equal to 2 times 24. And our 26 is 2 times 13. And that's our V sub 1. So we have 24 over 13 is V sub 1. What that means in terms of the circuit, in terms of this circuit, is that the top node, I'm going to put a circle on the top node, or let me get the highlighter. This here, notice that all of this is just pure wire. This is considered the top node, and it's at the positive because it doesn't have the ground. And from there to the ground, regardless of which node you go through. Your voltage is V1, where V1 turned out to be 24/13. V1 equals 24/13. And now from there we know all the other ones. Like for instance, our I2. Let me get a different pin. You can get your I2 there easily. Your I2 is equal to 1/2 times your V1. Run out of paper there. I'm gonna erase some stuff. I hate to do it, but I'm gonna erase. How about we write it here? Our I2 is equal to 1/2 times our V1, which is 24/13. Which equals to 24/26 amps. I don't like this number though. Let's put something like 12/13, because we're reducing it. So we got our right, and that's our I2. And the same goes for this guy here. Divide by 3, and we get I3 equals to 1/3 V1, which is equal to 1/3 times 24/13, which is equal to 8/13 amps. So we got the third one. We got an I3 and an I2. We got these two, so putting those two in there, they're just numbers. But once you add them, well, let me do it. I1 plus, we'll leave our parentheses, is equal to 0. And we have I1 plus I2 was 12/13. And I3 was 8/13. So 12/13 plus 8/13 gives you 20/13. And that's equal to 0. Take it to their side and we get I1 equals negative 20/13. So notice that our I1 on this branch, we said that it was pointing down, but the negative means that it's actually pointing in the other direction, which is consistent with this battery, that it should be pointing that way. That's if we remove the sign, but if you leave the sign, it means you have the negative, which is consistent. Well, if you saw this the whole way, I want to thank you, because look at all the mess that I made in trying to explain it. And if you're new to circuits, I wish you the best of luck. And I tell you that I really appreciate it for your patience and watching me scribble this. It reminds me of my college days when professors didn't know how to. Well, I shouldn't mock them. They're great and they taught me this stuff. But look at the mess I made, and I'm hoping to get better with this Wacom, or maybe buy a better device if this isn't suitable. so I can continue hopefully sharing some knowledge.